Hello, hello, John here. Let's hook a joystick up to the Nouveau so we can play some video games. Thank you to all my likers, subscribers, and patrons, especially the VIPs listed here. Thank you very much for supporting my channel. Alrighty, what do we do here? This is simple. All I did is I modified the top file and I modified the PCF file. Why don't we go ahead and take a look at this one first, since it's the smaller. Changes, I simply added these lines, which should make a certain amount of sense. There's an input bit for each of the up, down, left, right, and fire buttons on the joystick, as well as a button 2, because I was hoping to add a second button and play around with that as well, but I don't think I got that far. Point is, you got the pull-ups turned on, and you've assigned pin numbers to all the inputs where we're going to hook up the switch buttons. Last time I recorded a video about a joystick that I got on Amazon because I couldn't find the one that I normally use, and I opened it up, and lo and behold, it was nice and simple, easily hacked, and it looks like there's a whole bunch of these out there on the internet, and a lot of people do exactly what I'm doing and hook up custom controllers to them. So this is a pretty widely available thing. Very, very thankful for that. Keep in mind, this is not a SNES or anything like that. These are direct inputs from the individual switch wires from the joystick, which is how the Atari joystick, the original 2600 style Atari joysticks work. I talked about that in my series on the Z80 Retro when I did the VDP card with the joystick ports and all that on there. So if you've been following along on my channel, you already know about the joysticks and how they all work and all that fun stuff. If you don't, I'll try to add a link in the description below the video, and you can see what I had to say about the joysticks and how they work over there. All right, so here's the top file, and that's what I modified. Now, I'm playing around with some other things in here too. Some of you might recognize this thing as an audio, a sound generator chip that I've been dabbling with because, we play these video games. I want to hear what's going on. The Retro doesn't have one. But, you could certainly add a plug-in board to the Retro to get it. But I went ahead and implemented one here. So if you're following along and you grab this, you may notice that it'll do even more than just add a joystick, because we now have sound, we got sprites, and all that other fun stuff going on. But right now we're talking about the joystick. And if we do a git log stat on just this one file, if you're not familiar with Git, what this is going to do is say, show me all my comments that I made every time I did a commit on this top file here. So I can go back and I can look and see, oh, look, I added some stuff that had to do with the audio and some other audio stuff and so on. And down here, this is when I started adding the audio stuff. And I played around with the interrupts. What else going? Add a joystick input. So here's where I added the joystick input and what I added it to. Some older versions down here. So the way you do this, the way I find handy, so where it says stub in joysticks, down here, I was playing around. This is from long ago at this point. So I want to see the differences between before I stubbed in the joysticks, which go to the top file, and play around. Looks like I removed, this I remember. We'll see it in the diffs. This was just a commented out block of visual noise I was removing from the file while I was in the neighborhood. And then here I finished the modifications to add the joystick inputs. And the way you read this is 36 lines that are changed, and 12 mostly removed, added 2, and added 10. There's not a lot going on here. This went in quite smoothly. So that's about the whole thing. So what I want to do is I want to see the difference between this version here and the version down here. So what I'm going to do is grab another window and just paste this in so I have it saved. I can grab it with my mouse again later. So that's where I'm going to start from, so the diff looks like it works in order. It says you added these lines and remove those and so on. And that's where I want it to end. Of course, I'm thinking out loud. I should have done it the other way around, but here's how you do this. You say git diff revision, okay? And then you want to say, I want the old one, so I save that over here. I'm going to double-click it and grab it, paste the old version, ... and then the new version, which is probably still on my screen, please, right there. This is the version when I have that comment that says I added it before I started playing around with other stuff for the sound. So I say git diff version, the old key, ... the new key. And oops, I don't want to look at the whole universe. I just want to look at the top.v file, right? So here's the differences. What did I do? Clearly, I added some input signals to, to hook up the wires from the joystick, and I have to have a way for it to output the data. And if you've been following along, you would know that the port F0 is how the CPU accesses and reads the SD card data. And that one went away and was replaced by these three lines here. And you can see there's still the F0 input, but rather than having an F0 data, I have a generic read data. And we'll see below, this may not be the best way to do it, but what I did is I basically created a mux with a latch that says if it's reading from F0 or joystick 3 or joystick 4 inputs, I'm going to just stick it in the same latch regardless of what it is. I'll read it and stick it in a holding latch, and then up here, this code is the code that gets executed when the CPU is actually doing an input cycle, and the top level has to decide what data to send to the CPU. And I went over this before. It's either going to read from the ROM, or it's going to read from our new register here, or it's reading from the VDP, or it's not reading at all, and we don't want to send it any data. Okay? So what do? There's a bunch of pairs of these I talked about before for reading things like the SD card inputs and so on inside the top level logic, and this is just a simple decoder. So to read from joystick 3, what I'm looking at, I want to know that there's an IO rec read from the CPU, and this is in the CPU clock domain, and I want to know that the 8-bit value on the address bus is A8, and that matches the input port on the Z80 Retro board. So this same exact code will work on the Retro or the Nouveau. All right, and then there's this tick variation here, which is a little bit more synchronized to the phi clock. It's going to be true for only one single clock cycle when the address bus, and then when the address bus is set to the A8, right? And this IO read tick, I explained this before, is true when we're doing the IO rec read, and it's only true for one clock cycle. So it's a tick signal, a single pulse to load a latch. And the same thing for the other joystick down here, which is at address A9, okay? So then what do we got down here? Some old stale comments that I threw away because they're no longer applicable. And I was kind of a slob here, I admit. Well, this code needs to be refactored and cleaned up at some point down the road. I just wanted it on so I could play a game. So what I did, here's what used to be in there that read the data from the SD card. And you just saw that I removed this F0 data thing and replaced it with this read data thing down here. So what I do is I say, look, if the tick signals that you just looked at for the read R3 tick and the R4 tick, what it's going to do is it's going to say, grab a copy of what's on this bus, on these signals, and stick it in my RD data latch. Okay? But only one of these will be true at a time because each one of these has a separate address decoding, which works like this up here. So there's the J3 tick, the J4. There's going to be an SD tick that looks just like this for the port that the SD card is on, which is obviously F0. And because I'm inconsistent, I decided that I would name the SD and put F0 after the port number, and this is J3 after the function that is being performed on the port. And when I go through and clean this, maybe I'll make these all more consistent. But nonetheless, the bottom line is that in the CPU's domain, I have a single phi clock tick cycle every time the phi goes, depending on what's going on. If there's a tick signal from the CPU says I want to read you know, the SD or the joystick or whatever, it latches the data into this latch here so that the code above, the mux above, can decide whether or not it needs to send it back to the CPU. And that really is the whole thing. What's going on? Deleted some blank lines here, changed some comments, deleted commented out garbage, deleted some more commented out garbage, which was obviously me stubbing in the joystick from the get-go. This code here was simply uncommented and then moved above. Those lines there are what appear up here now. Okay, that's the whole thing. That's all we got to do. We got to get the pins in to the top level module. You can look at it a bit more, a wider context. It's near the bottom of the file. So if we scroll up from the bottom, here's this new always block that we have now. You saw me delete the old stuff and replace the SD card with that guy there. It's a little cleaner to see the actual. You can also see that J3 and J4 really, and I put a little XXX marker comment on this to let you know that this is not right, but because what I'm doing is I'm reading the same thing that I do up here, and that is whether you're reading for Joystick 3 or Joystick 4, you get the same thing. Not optimal, but I don't have two joysticks, and I wanted to just send something back, so I'm just going to send the same bit values back to the CPU, regardless whether it's reading Joystick 3 or Joystick 4. But otherwise, it's the right thing to do. And up here you can see these are the joystick signals. I commented out, why did I do that? These are probably commented out because they never got used. And what am I looking at? Here's the F0. This thing is the thing that reads the SD card. So each of these pairs, whether I'm reading or writing, you see that there's the read F0 is an asynchronous signal that is true or valid, I should say, for the full duration of the read cycle from the CPU, and that I think is just up here. IO-rec read is true when the CPU has IO-rec on, and read is on at the same time. And then just like memory and read would be memory read and so on. So this is purely asynchronous, and this one is synchronous-ish. The read tick is moderately synchronous, but to the phi clock. So this IO-rec read tick, where is it? IO-rec read tick is true. What do we do here? We create a synchronizer. I talked about this at great length in an earlier video and why I did what I did to latch it on and stretch the pulse and make sure that it's valid long enough for the other logic in here to use it. And like I said, it's synchronous, but it's still in the phi clock domain here. All right. So that is how this whole thing works. It was really easy to just throw this in a few minutes. So that's why I did it. I just wanted to say, hey, here's how this thing works. You can then compile it up and then program it onto the board. Then we can make use of it for whatever we want, like playing Space Invaders.